Okay, so in this video, as the title says, it's going to be about power and specifically powering a desk. The first subpart was Chapter 3, Footnote 1 actuator, and it was basically always making it so that this actuator would always be a certain distance away from the ceiling. The next part is going to be Chapter 3, Footnote 2 power, which is this video. I wanted to have a number of 120 volt outlets for just general purpose heat gun, whatever it is. Then I want to have some DC power supplies on there. And lastly, switches that are going to be for turning the lights on, killing power to the whole desk, killing power or turning on power to the actuator, that kind of stuff. So we're going to start with some drawings and then move on to 3D printed parts, wiring, and then some demos. Okay, so we finished the check fit. Nothing is wired on the inside of this. This is just making sure that everything fit the way it should. So we have the switches on the top. We have the 120 volt connectors on the bottom. They look like they're from a house because they are. Somebody was getting rid of them, so I thought it'd be great for a project like this. This middle section is that variable DC part where we have 1 and 2 and their associated connectors on the bottom. On the side, we have a quick access spot. So if I pop it out, you can just feed cables in directly, or if you know the connector, you can remake this with that exact connector. On the back, we have the spot where cables can come in and exit. On the bottom part of that, you can actually see the zip tie spots to make sure that the cables can stay kind of tidy. And then we have this grill spot so fresh air can come in. So on the back side of here, you can see that the general plan is going to be cables come in, 120 volts, plug into some of the switches, maybe route it down to the 120 volt outlets, and some of the other switches routed to other things. So for the DC section, these components allow you to adjust the voltage of the DC power supply, but they themselves, these two pieces, they are not power supplies just by themselves. They can adjust a power supply that's going to be external to this. So that power supply is not going to sit in here, it's going to sit externally, and you'll see that down the road. we now have two parts to this project. Starting with this, we have that same control interface. We wired it up, and through this cable, it gets routed to the bottom of this power box. The cable, by the way, is from old vacuums. So if you ever find a vacuum on the side of the road, or you're gonna throw out your own, save parts to it, because it's perfect for projects like this. So on the bottom of the power box, we have an AC line in, 120 volts, and we have the cables from the panel to this guy. We have 48, 12, and 24 volts for DC supplies, which are turned on and off by switches 1, 2, and 3. The fourth switch right now is not used. Some future project I might add it in. So before I get into the details of how everything was wired, I want to just let people know you can skip ahead to the demo of how this stuff works. So it'll be the switches controlling the supplies, DC outputs, and AC outputs. But if you're interested in seeing how and why everything was wired the way it was, stay for the next section. So starting with the switches up here, we have switches 1, 2, and 3 controlling the 48 volt, the 12 volt, and the 24 volt DC supplies. Right here we have the DC output, so this 24 volts can be regulated down to be between 0 and 24 volts, either here or here. These are a banana connector, I believe. This is an ATX connector, so you can use either one. On the bottom, we have the AC outputs, which are independent of these switches up here. So if you're charging your phone and you have these off because you want to turn off the power supplies, you can still charge your phone. So let's talk about the actual wiring on the back of this. So moving to this side, we have the AC connection. Those three connections are the live black, the ground green, and the neutral white. I have them directly actually leaving the box and through this wire coming to this spot right here. Those three connection spots go to the outlet here and here, where you have the hot black wire on the top, the neutral on the bottom, which is the white, and the green earth ground that goes to the green screw terminal on the actual outlet. And it's the same thing on this side as well. You're then taking two of these, the green and the black, and you're routing it up to the top where you have the live that's connected to the top portion here, and the green, which is connected to the chassis, again, that green screw terminal. What this does is it allows the switches on the top, the live, to either be connected or disconnected and routed through the yellow portion and out to this terminal down here. The yellow portion down here then gets routed to this spot right here. So you have the clear, black, red, and yellow. You have clear, black, red, and yellow. And what that is going to do is it's going to say if this switch right here is on, you will turn on this supply. This is on, this supply. And if this is on, this supply. Let's just go through kind of a scenario of that. You have this one. If you were to turn it on, it's not connected right now, right? But if you were to theoretically turn this on, it turns on power to the 48 volt supply and sends 48 volts out to this point. What this will let you do is connect something to this point that would take that 48 volts, which in this case for the desk video is going to be lights. You'll see that in the next video. Moving on to the next one, to turn this guy on, if you were to flip this on, this turns on this DC supply. This gets AC, it converts it to the 12 volts that gets routed to this point, and you can connect something here that's 12 volts. And in this case, that's going to be an actuator that you might have seen in Chapter 3, Footnote 1 actuator video. If you haven't, go back and watch that because it'll show what this is going to be powering. And in this case, it's going to be two actuators. That's going to be shown also in the desk video. So moving on to this last power supply, which is going to be this switch. If you were to flip it up, this would give AC power to the 24 volt supply that would be converted over to the DC 24 volts. And if you were to follow the color codes of the brown and the blue, you see that you have brown and blue here, and they're fed up to this guy and this guy, converting the 24 volts to be anywhere between 0 and 24 volts, and it does it independently between these two. That's then routed to either that ATX connector or these, I believe the name is the banana connectors. The next stage here is going to say, let's actually turn it on and plug in this cable and see how everything works.
It's like a dream.